This question is on kinematics. You are given a car accelerating uniformly, that means constant acceleration from rest from t equals to 0 along a straight level road. The car travels 12 meters in the time from 1 second to 2 seconds. So how far does it travel in the time between 3 and 4 seconds? For such question, it will be easier to help you by drawing out the speed time graph. Alright, so we can put in the values, and another thing, because if it travels 12 meter, the distance is 12 meter, that should be the area underneath the graph. So in this case, since it's a constant acceleration, the graph should look like this. Alright, now just to sidetrack a little bit, if it's constant acceleration, let's say it's 10 meter per second square, let's use this acceleration due to gravity as an example. What do you mean by an object undergo free fall 10 meter per second square? It means to say every second, the layman term is every second the speed will increase by 10 meter per second. So it will be 1 second, the speed will increase from rest to 10, and another second later the speed will increase by another 10, it will become 20. That's what it means, and the understanding of this is very important. Now let's go back to the car here. Let's put here 1 second in equal interval, 2 second, 3 second, and 4 second. And the 12 meter basically means the area underneath the graph for the first to 2 second. So if I were to shade it, that will be this shaded area, that is 12 meter, and this information allows you to find the unknown here. If I can find the speed or I can find the acceleration, and what you're required to do is to find how far it travel from the time equals to 3 to 4 seconds. So this is the portion, and to find the what's the distance travel, basically you have to look for this area underneath the graph shaded in pink. Now let's go back to here. If I use the formula A equals to V minus U over T, because for this situation, just like the car, it starts from rest, so the initial speed will be 0. So what you're left with is V, your speed, is equals to AT. So if I think about this case here, for 1 second, the acceleration is 10 and the speed will be 10. Okay, at 2 seconds, okay, acceleration is 10 times 2, that will be 20. Alright, that's what it means. So right now for the car, I'm going to introduce x, the speed of the car at 1 second. So if you understand this, that also means that the acceleration, the constant acceleration, is x meter per second square, because you can just take that your v minus u, your final speed, which is your x minus initially starting from rest, over 1 second, that will be your x meter per second square. So that's what it means. But you don't think about the acceleration first. Let's go back to the speed. So based on what you have learned here, if here is x, 2 seconds later this will be 2x, and 3 seconds later this will be 3x and 4x. That's what it means, a constant acceleration. So the first information that's given in the first paragraph here actually helps you to find the unknown x. Alright, so 12 is the area underneath the graph, and it's a trapezium, so you use the area of trapezium, half times sum of parallel side, which is your x and 2x, and times the height between the two parallel side, which is just 1 second. Alright, so if you solve it, 3x will be 24, your x will be 8 meter per second. So this will be 8 seconds meter per second, the speed. This will be 16, this will be 24, and this will be 32. And of course, like I mentioned here, the acceleration will be 8 meter per second square. Okay, but like I say, we need to find the how far the distance travel from t equals to 3 to t equals to 4. So basically I need to look for the area underneath the pink color shaded region. So distance is equals to, you apply your area of trapezium again, but now the distance, the speed here will be, the height here will be 24 plus the height here, which is 32, and once again the interval here is just 1 second, and if you solve this, you will get half times 56, and that will be 28 meters. Alright, so the answer is A. Alright, thank you, bye bye.